One.
Live.
Okay.
Do you have notes, please? So we can.
You don't. That's why I asked you to get paper out.
Do you have like an introduction for every single one of these?
Yeah, just introduction.
All right, Jake. That's exactly what I'm talking about not doing.
Alright, I'm actually gonna.
Hey, here's a list of all the things that period 6 came up with when I talked about solids. Is there anything else that's not up there that you guys can think of that you can remember from that unit about solids?
Cube
root, radius.
Yes, sir. A cube, yeah.
This is a star because I don't know how to use it.
Square root.
That was like an 8.
I mean, I know that the volume and stuff, but like the circle.
Formula.
Huh?
Yeah.
Formulas. That one's better. I think I've got surface area. Not only that, but I have lateral surface area.
I need.
What about the base?
Okay. All right. Well, let's get into it here. So the way I've broken this up is piece by piece. Here are some problems I did with 6th period. All right. So we started with the basic shape of a cube, and I asked, can we find its volume? Right. It ended up, it's just the length times the width times the height. Does anybody know now why we call, or when we raise something to the power of 3, what's another term for that? Cubing something, right?
Yeah.
This is the reason. Well, because if you had a cube and each side was 4, what would be the volume? Oh, it's 4 cubed, which is 64. The volume of a cube with each side that's 3 is 3 cubed, which is 27. The volume of a cube with each side measuring 2 is 2 cubed, which is 8. So that's why we call it cubing, right? Because it makes a cube. Okay, this one was a little bit more complicated. It was a right triangular pyramid. The base of the pyramid was a right triangle. The formula, if you can see on your formula sheet, was 1/3 the area of the base times the height. Now, I think the part that gets confusing for kids is this big B. How do I find big B? That's the base.
Yeah, I don't know how to find big B.
It's the represents the area of the base, and since every shape doesn't have the same shaped base, big B is what's called a dynamic variable. Because it changes. Okay. So in this case, big B is the area of a triangle because the base is a triangle. Okay. So 1/2 the base of the triangle times the height. Here I had to do a little bit of work. I had to do a little bit of work to find out that this was 4. It's a 3, 4, 5 right triangle. Okay, and then I was told the height was 7. All right, so that came out to 14 units cubed. If you don't write units, that's not going to be an issue, but you should. I haven't been stressing it this throughout the year. So if you don't write it on your test, I'm not going to take it because I haven't been talking about it. Okay. This is a triangular prism. What's the base?
It's the rectangle.
It's a triangular prism. What's the base?
Triangle.
The two over
It's a triangle. But Joey, you said the base is a rectangle. Why? Why is the base this rectangle here?
Doesn't have to be.
Because that's what it's sitting on? Is that why you're saying that?
No, but like, I mean, I guess if you like sit at some triangle.
Okay, so common misconception is that the base has to be the thing that it's sitting on, and that's not true. Like this cylinder here could be sitting like this. Obviously, the base isn't that line of tangency. It's the two circles on the end. So in
this type of shape is.
Right, and if they don't tell you the name of the shape, the bases are the two faces that are both parallel and congruent.
Parallel and congruent.
Yeah.
How does that work for square pyramids?
It doesn't because there's only one base.
Yeah. But
It's all right.
it says the name and
It's all right. Okay, so for this base times area of the base times the height, to find big B, it was a triangle. Okay, the height of the triangle was 4, the base was 5. So I got the area of the base to be 10. The height, this height here is the height of the solid, which was 10. So this volume came out to be 100. All right. I know I'm running through these examples really quickly. We'll come up with some examples of our own to do. So here's a square pyramid. Square pyramid, the volume is again 1/3 the area of the base times the height. So I had to find the area of the base. Since it's a square, the area of the base is just 6 times 6, which is 36. And the height here, I had to find the height. I was given the slant height, and I know that this distance should be half one of the edges. So this ended up being a 3 blank 5 right triangle.
3, 4.
Right. Or you could use the Pythagorean theorem and get the h squared was 16, so the height had to be 3. All right. Here's an example of a compound solid.
Don't even know what that is.
So what that is a rectangular prism that has a scoop out of it.
Like a half circle.
Wait, so it
in that-
only can be then?
Huh?
It can be other.
This is just an example.
Oh, okay, I was.
That scoop is a semicircle. Or, excuse me, not hemisphere, a hemisphere. Okay. So what I did was I found the volume of the cube that the entire sphere fit in. I subtracted the volume of the entire sphere and got this. Volume of the cube minus volume of the sphere. And then I divided the whole thing by 2 to get half of that shape. Remember when I showed you a sphere inside of a cube? Yeah, I don't know where my cube is. I was trying to show you guys, I showed them yesterday. All I have is my sphere and it's cracking. I don't know why people steal my stuff.
Oh, here it is,
here it is. I found it. All right, so remember, so there's the sphere inside the cube, right? Imagine taking the sphere out, so there's an empty ball in the middle, and then cutting this in half, right? I found the volume of the cube, found the volume of the sphere, subtracted the 2 to get the area inside, and then I cut it in half by dividing by 2 to get this. Okay, that's not the only way you could have done that. There are multiple ways that you go about it.
Orders.
Right. All right, so is there a particular volume problem that you guys want to work on? Maybe a
Let's do the volume of
Yeah,
a.
that.
Like a
Cylinder.
Okay, cylinder. How about,
Can we do one of those ones where there's like a shape, not a shape? Got it.
we just did, all right, let's do this one. How about this?
So should we do this on our paper with you?
Yes.
Alright. I have no idea how to draw it.
I don't even draw that. Well, couldn't you just find? So that's a hemicylinder.
Yeah, half a cylinder.
Look at my hemicylinder.
Okay, so I want to find the volume of this half a cylinder, right? Half a cylinder is not a big deal.
It's not hard.
Okay, so I should just find the volume of the cylinder, right? Now, remember we said that a cylinder is just like a prism, and that to find the volume of it, I find the area of the base and multiply by the height. So the base here is a circle. Area of the base times the height. Here's how I would find big B is a circle.
Isn't it pi r squared then?
So big B is pi r
Oh,
squared.
12 times
What is the radius of
4
this?
squared.
3.
Wait, what?
Oh,
What? Wait, is that an 8 or a 6?
6.
That is 6.
because the diameter is.
Wait, which one is the circle? The thing on the bottom or the thing on the side?
It's lying like this, and then I cut it.
So it's the thing on the side?
What? This is
That's the,
this is the base.
oh,
Okay. So the area of my base is 36 pi. The height is 12. I don't. Can someone tell me what 36 times 12 is?
Wait, how do you get 36?
360 plus 31.
Stop touching.
yeah, isn't it 3 squared? Not 3 squared?
Yeah, isn't it 3 squared?
It'd be,
Because it's radius.
Oh, yeah.
4.
I'm sorry.
So it's 6 times 12.
It should be
420.
9.
Dang.
I mean,
Because
don't know.
it's 3 squared.
oh, yeah. So
Okay, and then 9 times 12 is 120
It's 108.
minus 12. What?
108.
108?
108 pi divided by 2.
We can roll out and do it like that.
Okay. So
Pi units.
Why do you divide it by 2? Oh,
Because we only
sorry.
want
It's only half, it's a hemicylinder.
all right, just don't need to get out.
Yes, sir.
Okay, so volume, how do we feel?
Volume's pretty simple.
All right.
And you just use that field thing to get it back to like the squares.
You're just remember, you're just using the formulas.
Yeah, it's pretty simple.
I'll go back at the
I
end.
still really get it.
So unit 10 is solids and unit 11 is
Transformations.
Translation, right?
Yes, okay, shh. Okay, surface area. Here's a cylinder. I tried to recreate the example I showed before about taking this cylinder, cutting it down the side, and then unrolling it. You see here the cuts?
Yes.
Okay, so the height of this rectangle is just the height of the cylinder. And this length is the circumference around. See, I can do.
Should we draw this or something?
I would just watch.
Yeah,
Yeah, I'm just.
just so.
Okay. So to find the surface area, the first thing I'm going to do is find the lateral surface area. The lateral surface area is the area around, not including the top and bottom. Okay, so it's just that stuff that wraps around.
No, it's not the basis.
It's not the basis. So to get the circumference, it's 2 pi r. So my lateral surface area is 2 pi r times the height. Okay?
Oh, we are trying to find.
Right. So I ended up with 36 pi, or about 113. We're going to use the 36 pi. The total surface area, I need to add in the bases. There are how many bases?
2.
2. Each base is a circle, so pi r squared is the formula I used. And I want 2 of those, so 40.5.
Yeah.
Okay, so my total surface area, 76.5 pi. Hey, guys, I want to just let you know that I looked at the test and I'm literally going question by question. So focusing and paying attention would be wise. I'm trying to help you out.
Is this gonna?
Wait, what, so is that, you know this,
It's recording right now,
you know the circumference thing?
but that doesn't mean don't pay attention. Right?
The circumference thing, is that different? Why did you do that?
Yeah, why did you need to find this?
If you look at your formula sheet, tell me what it says for lateral surface area under the cylinder.
It's 2 pi r times the height.
Wow, I'm fine.
Yeah, I'm asking because were you trying to find the surface area?
Initially, I just wanted to find the lateral surface area.
Oh, okay. I thought you were just trying to find the surface area, so I was confused why you didn't use all
Well, because I broke it up into finding the lateral surface, because you will have to just find the lateral surface area for some problems. It'll specifically say, what is the lateral surface area of this figure? Okay. All right. Now, this problem I drew and realized I had made it much more difficult than anything you would see on your test. So I did write skip. You won't do because it's a rectangular base. So don't need to worry about this problem, but we will do another surface area problem for a cone. That's a bad circle.
That's called an oval, right?
That's called the square.
I can look at that. I could stop. 6 periods already had their review.
It's a pretty good one.
Okay. We want to find the surface area.
What if you had the like the this? Oh, never mind. No, just did it back.
Right. Okay, so the surface area of a cone, does anybody, can everybody find that formula?
Pi r
Pi
squared
r
plus
plus pi r times the L.
Okay, actually, let's start with just the lateral surface area.
That's the L, right?
Yeah.
Pi r L.
All right. What is that L?
That's the length of the.
The length of the.
It's the
the
side.
side height. This is- No, no, not that one.
It's the hypotenuse,
That one,
it's the
that's the side
hypotenuse
height.
of the triangle.
What's that?
Okay, so this is L.
Oh, Pythagorean theorem.
Right, I could use the Pythagorean theorem. 5 squared plus 12 squared equals L squared. Or I know
It's
it's
the triangle.
It's
13,
13.
right?
So, you found our L, right?
So pi, I know my R is 5 and my L is 13. So my lateral surface area is, can someone calculate that?
That's 500?
Yeah.
So it's gonna be 5 times something, so 65. 5. So whenever it says L, you're trying to find the lateral surface area?
No, it's
No, that L stands for slant height.
Yeah.
If you look at your formula sheet, it points out where L is in your shape.
Oh, yeah, sling height. And then LA is
Lateral surface area. Okay, now B, you want to find the total surface area. That's the lateral surface area plus 1 base. Right, there's 1 base. Is that 2 bases?
Yeah, that's one base.
It's only 1 base, right? So I'm going to take my lateral surface area, 65 pi, and add to it the area of a base, and the base is what shape?
A circle.
Which the area?
Fire squared.
Oh, we already did all this research.
Right. So 65 pi plus pi r squared, which is 25 pi. $90 pi.
Oh, wait, would it be 95 squared?
No.
Units squared.
Because, wait, what did you square pi?
No, not squared pi.
Plus pi.
Not squared pi.
But you see what I'm saying?
Oh, because there's 2 pi's here?
Yeah.
So question, what is 2x plus 3x?
5x.
Why is it not 5x squared?
5x squared.
Why is it not 5x
Oh,
squared?
no,
multiplying.
they're not. Oh, is it multiplying when you do that?
You're right. 2x plus 3x is 5x. It's the same thing as this. 65 pi's plus 25 pi's is
Oh, because pi is a number.
One
Pi is a
value.
number.
right.
I'm stupid. I'm bad.
I know, right?
It's just other. What's up?
For part B, what's right in front of these?
1. There's 1 base.
Pi is a number. Stop.
Okay. Are there any other questions about surface area? Okay, then I want to do here's one compound solid surface area problem. I think you've seen this
Those are
problem.
easy.
Oh, yeah.
Let's do that.
Is this on the SOL?
Yeah, there was one. I didn't find it.
Wait. Yeah, see, I didn't. Yeah, I got this one wrong with that. So there was a question just.
So here's the thing. Here's the thing. I don't have a cylinder that's this size, or I don't have a cone. I don't have a sphere that's this size to put on top of here to show you. So just imagine that this is a sphere, or a half a sphere. If I put this half a sphere on top of this cone, is the base of this cone now part of the surface area?
No.
Wait,
It's not on the surface.
If I put these two shapes together,
Yeah.
are these bases now part of the surface area?
There's no base.
No, there is
They're
a
on the
base, but-
inside. The surfaces sort of disappear, right?
What would be the surface
So it's
area?
just,
I mean, not the surface
the
area,
mistake
base,
that
but
may have been made here is finding the surface area of the sphere, great. Dividing it by 2, great. And then this is where you may have made your mistake, that you found the entire surface area of the cone. Like if you just relied on the formula sheet and didn't think about what surfaces were being shown,
Base.
the base isn't being shown, so the only part of the cone that I need is the lateral surface area.
Yeah, you don't need the base of the sphere.
It's not part of the
And then
surface
I-
area.
You don't need the area of the sphere.
Add those two surface areas together and I get 90 pi. And that's just
Oh, that's just an easy one.
There was a question, I'm pretty sure it's the exact same. Like, who's best?
I know.
How do you know that?
I don't know.
There was questions
Are you a
that
serious magician wizard? A powerful magician?
He's a level 90, but.
He's a level,
90 warlock.
he's a witcher.
All right, ratios. Because this is also on the test. So remember, we have 1-dimensional ideas, 2-dimensional ideas, 3-dimensional ideas. Okay, here are some things that are 1-dimensional. Length, radius, diameter, circumference, perimeter, height, width, slant height. Notice that these are all dimensions of individual shapes, right? Like the radius.
That's one.
the diameter, the circumference, the perimeter, the height of something, the width of something, the slant height of something. They all represent individual dimensions of solid shapes. That's why they're one-dimensional ideas. Two-dimension represents some sort of area, right? So area of a circle, lateral surface area, total surface area. Big B is two-dimensional because it represents the area of a base. And 3D, the only thing is volume.
Wait, can we do something?
About 40.
Yes, we are. We're gonna do
Well, I'll just remember this.
a chart like this.
We just did that like before the.
It was similar, but not exactly. Okay, so let's see. What if I gave you a scale factor for two shapes that was 5 to 3? What would be the ratio of areas?
25.
Yeah, 25 to 9.
Gosh, can I test the class?
How did you get 25 to 9?
I squared it.
Squared it.
Then you just
Squared each other.
Huh?
125 to 27.
Yeah. You go, Jimmy. You go, Jimmy.
Thanks.
What if I told you that two shapes had a ratio of areas 81 to 49? What would be the ratio of volumes?
You would square root and then cube and then cube. You have to do the square
It would
root.
be the cube root of 9 and 7.
Yep. Okay, no, this is something. This is what you do. You know this symbol that's like this. Yeah, you do that over 81 and then you do it over 39. At 49, that's gonna be your surface.
Okay, so I think the general consensus that I'm hearing is that I can't get this until I have the scale
You
factor.
can't go.
Yeah,
you can't do
Okay.
everything.
So I need to first get the scale factor by taking the square root of both of these numbers.
Yeah, 9 and whatever.
And then I
you
can
do the
cube
volume.
them to get,
Like 8.
You square that, which is,
What's 9 cubed?
I don't know.
That's like 81 times 9.
181.
180.
Every one of you has a calculator on your phone.
No, we're not.
I don't have
I want to do some.
729,
Okay, just
729.
9 times 9 is 81.
Mr. Menace is even.
How did I get that faster than everyone?
729,
Harder than
343. 343.
Your phone, wait, is that 6?
Yeah.
343 minutes.
Why is that one?
Which one's the 343?
729 per universe.
Okay. Did that make sense?
Oh, yeah.
On the front page you use this.
Easy. Oh, the
Easy cheese.
front page of my test.
Okay. So here's some interesting examples. Say I have a cylinder, it has some volume. And I create a new cylinder that has a volume 4 times as big.
I'm guessing this might be.
And then it might say what statement is true. Let's see if we can maybe just do a free response here and not have choices to guess from, and give some true statements about the dimensions of the new cylinder.
Okay.
So we'll say,
Yes.
what
So it's a,
can you say
does it say 5 or 4 times?
about the new
The radius would be 2 times bigger.
How do you know
I don't know.
Well, if the volume is 4 times.
Yeah, radius would be 2 because.
So, well, since radius is 1D,
Volume is 3.
Well, this is a tricky one.
Hey,
Volume is.
what's the volume of a cylinder?
Pi r
Pi r
squared
squared times height.
Okay.
Okay, so basically, if we plug in a number, like to multiply one of these dimensions by, we want it to end up being 4 times as big.
Yeah.
So, think about a cylinder. If I stacked 4 of these on top of each other,
Okay.
wouldn't the volume be 4 times as big?
Yeah. So
And
height would be 4 times bigger.
Okay, so the height,
Radius would stay the same.
so
Well, maybe.
No,
No,
yeah.
three.
1,
The radius is 6.
What is it?
Oh yeah, but you're stretching it, right?
Yeah.
Like, you can-
I mean, you can do it that way as well.
I mean,
okay, so that's true. What could be another possibility?
Um,
Is there a number I could multiply the radius by to have the volume be 4 times as big?
4? To make it 4 times as big?
If I multiplied the radius by 4, I would have pi 4r squared h, and 4 squared is 16. So now my volume is 16 times as big.
So it's your 2.
So 2. And the height would stay the same. Okay. So let's see, if we said 2 times the radius, I would have 4, and the volume would be 4 times as big. Does that make sense what I did there?
Wait, you say the radius is 2 times as big?
It could be.
It could.
That's a
See, so I was right.
That's a possibility.
Yeah.
So, ask me a question about these, because I think this is the hardest stuff for me.
So why did radius only get 2 times? Oh, because radius is squared. And when you square a number,
Teresa,
Yeah.
you're looking a little stressed. Okay.
Let's say you're tired, so.
wait, so this means you drink a gallon of water every day.
Gabe, ask me a question.
What's your favorite video game other than Destiny?
Gabe, you don't have a question? Okay.
So, volume.
Yeah.
So, everything's what, so would everything stay the same besides the height?
These are the 2 possibilities. I have 2 dimensions in the volume of a cylinder that I could change. So there's only 2 possible changes that I can make. Change the height, change the radius.
No.
Yeah.
So the height is 4 times and then the radius, okay.
Right. It's one or the other.
Okay.
And you're not, I mean, we could make it more complicated before. Okay. Let's see maybe another example that's similar to this. How about the surface area of a box? I'll show you guys a trick here. Okay, so I've got a box. I want this to be an open box.
What does that mean?
It's open, and then one of the ones.
That is not closed.
Now it's open, right?
Oh.
Yeah, yeah.
Oh, that was sick.
All right. Okay. I have an open box here. Let's give it some dimensions. How about 12 by 12 by 4? What would be the surface area of this box if I multiply? What is the surface area if the H height is 2.5 inches bigger? That's a question mark. In other words, what would be the surface area of a new box that has its height increased by 2.5 inches?
Well, it's easy.
Oh, so you just plug it in there?
How is it any different?
Wait, I have a question. So this is surface area, correct?
Yes.
So wait, do you have to find surface area of the inside wall?
No,
I don't. You know what I'm saying, right?
I do.
But that's the
You don't have to
surface
worry about the inside.
Wait,
Just the outside.
Sure. Wait, wouldn't that be incorrect?
No, not the way it is.
Would you take off the other base? One of the bases.
Yes.
Yeah, you do have to take off
This
the-
is an example of where if you're not thinking and you just look at your formula sheet and say, oh, it's a rectangular prism, and I'm going to find the surface area, which is 2LW plus 2LH plus 2WH, and you do that, you're going to get the problem wrong, even if you add the 2.5 to 4, because you've added in the top, and this is an open box.
Would you divide it by 1/3?
No, just don't add in that other base.
What could you just subtract?
Okay? The easy thing to do here is to just try to use your widths. Aren't the sides of the box all the same? They're
Yeah.
12 by,
Whoa.
I got 6.
they're 12 by whatever the height is.
Yeah.
Okay. So let's,
Wait, can you show me like what you mean by take away one of the bases?
If I did a,
Okay, it's a big one.
I get that, I get
Okay.
that.
I've got a cube.
Yeah.
It's got 6 faces, right?
Yes.
Take a face away.
Okay. Yeah.
That's 5 bases.
Right.
So you can just find the answer and then subtract.
The box is
area of
open.
that
There's,
base.
the top is not there, so that surface
Oh, and
area.
then subtract one area, the area of the basement you don't.
Okay. So how many of these green areas do I have?
1, 2, 5.
And they are 12 by 4. Okay?
Oh, 4, sorry.
So the area is what, 48?
Times 4, yes.
So I have 4 of those.
Yeah, 2 144s. Okay. So couldn't you just find the surface area of the whole thing and then subtract 144?
hey, let's stop throwing paper, all right?
Yeah, please stop throwing paper. Okay, and I have, how many of those blue bases?
2.
1.
How many of those blue
Dude, we
bases?
just went over it.
It's an open box.
1.
It's an open box.
Okay.
Open.
Dude, it really makes me mad.
Hey. Stop. Don't be mean.
Are you okay with that?
So I have one of those, and its area is so I have 4 of these, one of those, add them up, what did I get, Will? Or miles?
I think yes, miles.
What is, was that right, 456? Miles?
Oh, wait, never mind. Here, I'll do it.
Not before 4:56. So,
Yeah, 3:36.
Minus 144.
no, because we only did one of those.
Okay, yes,
We
Joy.
found the area of the-
Okay. All right, how do we feel about unit 10 here?
We just added up.
Okay.
Yeah.
This is the time to let me know if you have any other questions about unit 10. What's up?
Wait, I think Jake might already asked this, but we could do it by way, right? And just minus subtracting
Just
it. to the
subtract 144 from the whole circle.
Yeah, and you would still get the same
Oh,
exact.
so
Yeah.
I find that.
That would be-
I feel like that would take a little less time.
Yep. Yes, sir.
Well, you didn't answer the question.
For what? Okay,
What's the P?
good question.
I actually have no idea what the P means.
That's just a.
Is that not for?
And for triangular prism, and you're talking about for the surface area? Lateral surface area and surface area? I want to put this in the surface area stuff here.
The P is for.
Okay, so let's make a triangular prism. Okay? Let's give it some, well, let's do this. I'm gonna cut along this